So for this recording, ngizobe discuss how section B alo. We did discuss section A sisonke. So I decided just to do section B one ngoba ngifila ngathi it's gonna take up much of our time. So if ever you struggle section B, analytical geometry, the second, just make sure that you stick around all the way through my problems, because I selected my problems lawa lapha clear document for a purpose. Some of them are challenging, so it's best to go to wayenze. After doing them, come back to this video and watch. Izokusiza kakhulu. Okay, so yeah, section B, analytical geometry. I'm going through all of the problems, ne? All of the problems. In case you have a problem, just ask me in the comment section yale video or ungangibuza lapho ku WhatsApp group yethu. Okay, but before start, I just want to mention a few things, more especially regarding ama straight lines. To find the equation of a straight line, you need two values, right? You need two values, as you'll see, or in case or if you have noticed, all of the problems are corner. There is a tangent. There is a tangent to wonke lama circles, right? So on one of the questions, it's either they gave you an equation of that tangent, which is a straight line, or you have to find the equation of that tangent, which is a straight line. So you need to know how to find the equation of a straight line. So now total equation of a straight line udinga two yezinto: a gradient and a point on the line. Then once you have these two values, then ungasebenzisa y minus y1 equal to mx minus x1, right? You can use this equation, or y equal to mx plus c to find the equation for that tangent, which is a straight line, by the way. Okay, so this is the side note I just wanted to make, né? So whenever you calculate or trying to find an equation for a straight line, in this instance a tangent, just keep this in mind. Keep this in mind. Okay, so now question 1.1. So lana, in the diagram below, we are given a point A, which is a point on the circle with center B, 1 minus 1. And then the line FG is a tangent. Tangent to the circle at point bani A. 1.1. Find the equation of FG, which is the straight line. Or find the equation of FG, which is a straight line. FG now. FG is a straight line, and it's also what? A tangent to the circle. So like 1.1, we want to find an equation for a straight line. So sitting at 2 years in, we need a point, which we do have as uA lapha, right? So that's the point we have. Sishotangani a gradient. How do I calculate the gradient? Of course, you can use this equation. My2 minus y1 over x2 minus x1. Ungayisebenzisa that equation, but udinga two yama points to find the gradient on any point. I mean on any line. So asna point, or let me say we need another point on that straight line FG to calculate the gradient, because on this line yaga FG I only have one point. I can use a gradient ka BA or AB, this line, which is the radius of the circle. I calculate the gradient for the radius of the circle and use that gradient to calculate the gradient for FG. Let me show you what I mean. So calculate the gradient of AB or BA. So gradient of AB is A minus B over XA minus XB. Alright, so bani i value ka YA minus 5 minus YB, or YB to minus 1 over, and then XA ubanu minus 1 minus, and then b u1. So we simplify, sithola u minus 4 over minus 2. So the answer is 2. So that's the equation of the radius. Equation of the radius, AB. Now, after finding the after finding the gradient of the radius AB, we can use the property AT. AB is perpendicular to bani FG. We know this from Euclidean geometry. A radius is always perpendicular to what? A tangent. So since AB perpendicular to FG, it's because of a radius is perpendicular to a tangent all the time. So sizosebenzisa the property of these perpendicular lines. Yoguti, when we multiply ama gradients of ama perpendicular lines, sithola bani minus 1. So the gradient of AB when multiplied by the gradient of FG, we are getting minus 1. Mina, I want the gradient of FG so that I can find the equation for the line FG. You substitute the gradient of AB, which is 2 mfg is equal to minus 1. Then we divide up both sides by 2. Cancel lana. Then I'm left with 2 mfg. This is equal to minus a half. Now I have the gradient of line FG. I also have a point that lies on line FG, which is minus 1 and minus 5. Then we calculate what? The equation for the straight line FG. So give about y minus y1 is equal to mx minus x1. So it's y1 y1, it's this minus 5. So it's minus 5 la. Gradient to minus a half. X1 ubani, it's this minus 1. So it's y plus 5 is equal to minus a half about x. Negative times a negative, that's a positive. Then you simplify, it's plus 5 minus a half x minus 1 over 2. Then go about y minus 1 over 2x minus 1 over 2. Then go about minus 5. I'm transpose. I want to make y the subject of the formula. So it's minus 1 over 2x. So negative 1 over 2 minus 5. You answer negative 11 over 2. So this is the equation gabani ga FG. Now they also want us to find what? The equation of the circle. So i-circle yethu, it's not centered at origin. Ne? It's not centered at origin. I-center yale circle ayikho e-origin. So sebenzisa this equation squared plus y minus b squared is equal to r squared. So lo a nalo b kwamele kube yini ama coordinates wani we center. So we're gonna substitute the coordinates of the center. So it's minus the coordinates for the center. So a it's gonna be the x coordinate of the center. So 1, close the bracket, squared plus y minus b ubani negative 1. It's the y coordinate of the center. Squared is equal to r squared. Then sibano x minus 1 squared plus over y plus 1 squared equal to r squared. Okay, then I will have to substitute a as well because it's one of the points that lies on the circle. So that things will calculate in a value r, right? So the equation, umabati find the equation of a circle. Udinga the coordinates of the center, which we just substituted. We also need a value gabani ga r. So in order to calculate r, you say coordinate like a to calculate r. So this is the next phase of a substitution. You substitute my coordinates ga a. What is the x value of a? Minus 1. So it's minus 1 plus squared plus then y it's minus 5. I substitute to minus 5 plus 1 squared is equal to r squared. So it's minus 2 squared. I'm going to simplify this. Minus 2 squared, it's 4 plus, and then it's minus 4 squared, that's 16 r squared. So you answer 20 la. So 20 is equal to r squared. Therefore, the final answer, 9, it's x minus 1 squared plus y plus 1 squared equal to 20. It's r squared on the right hand side. So ngithatha lo 20 ngimsubstitute njengoba njalo. Okay, so no x minus 1 squared. I substituted is center yami as well as the radius. Now I have this as the final equation. So this is the equation of the circle. Bese babuya lapha ku 1.1.3. If the distance from F to B, let's highlight this in red. From F to B. Now kusuka la izala ku B. Alright. But it's the square root of bani 69. But it's square root 69. And then but calculate to FA. I'm gonna highlight this in blue. Now FA. But let's also consider AB. This is what? It's the radius. This is the radius of what? Of the circle. So yabokuti lana it's what? It's 90 degrees, right? Ngoba radius, it's always perpendicular to what? The tangent. The radius is perpendicular to the tangent. Now, in order to get FA, which is the side of this triangle, let's draw. I have radius was square root 20, right? 20 it's r squared, but the radius it's neither. It's square root 20 is equal to, because I'm squaring both sides. After squaring both sides in total r, that is equal to square root 20. Now I have to calculate the blue side. You're saying so Pythagoras what theorem to calculate FA. So let's calculate to FA. So FA lapagu 1.1.3 9. It's gonna be FB, which is the hypotenuse squared, is equal to AB side squared plus UFA squared. So I'm gonna substitute ubani UFB, which is 69, square root 69 squared equal to AB. I do have, it's the radius, it's square root 20 squared, then sibano FA squared, then 69 equal to 20, then go about FA squared, transpose 20, 69 minus 20 is equal to FA squared. So I'm gonna calculate 69 minus 20. I'm getting 49 is equal to FA squared. So now square up both sides. I'm squaring both sides. I find that FA is equal to 7 units. Is equal to 7 units. So that's our answer again. Okay, FA. Now as answer the next question. Okay, oh, here we are. Alright, so this is the next question. I believe this one is a class in with some students. I don't remember Gutabuban, but anyway. So 1.2 given below is a circle with diameter KL, where UK it's minus 2 and minus 6, and then B, there's no B here. There's no B. I think I wanted to say L instead of B. Light should be L. Not B. My apologies. Our points on the circumference of the circle. Then go 1.2.1. Find the gradient of line segment KL. Find the gradient. So we have to find any gradient between point K no L. So let's do that. 1.2.1. So the gradient kuyoba KL equal to YK minus YL over XK minus XL. So what is YK? YK minus 6 minus YL ubani 2 over XK ubani minus 2 minus XL ubani 4. So we simplify minus 6 minus 2, that's minus 8 minus 6. So the answer is 8, it's 4 over 3. So the answer is going to be 4 over 3. This is the answer. This is the gradient of line segment KL. Then 1.2.2, determine the equation of the tangent to the circle at L. So, when maybe you can just draw a line yana like this, just to highlight or show the tangent. So we have to find the equation for this tangent. So, as I've explained before, udinga what? Two things whenever finding an equation for a line: a gradient and what? And a point. Here, sin a point, yilo L, u4 no 2. Sishota ngani nge gradient. Sishota nge gradient. So the gradient we just calculated, this gradient we just calculated, Naila, of this line, gradient of this line. We can use this gradient to calculate the gradient of the tangent. Ne? So sizoti gradient of tangent multiplied by the gradient of the diameter, or KL. KL, by the way, it's a diameter. So we know that, in fact, a diameter or a radius is always perpendicular to ilokai. It's gonna be perpendicular to a tangent. So KL being a diameter, uthatha gradient of the diameter KL multiplied by the tangent uzothola minus 1. So since thina sifuna the gradient of the tangent, I'm gonna leave that, and then gradient of the diameter we just calculated is 4 over 3 equal to minus 1. So we're gonna calculate the gradient of the tangent. So how do we do that? So divide up both sides by 4 over 3, 4 over 3. Lay cancel lay. So we have a gradient of the tangent, which is gonna be minus 3 over 4. 3 over 4. So this is the gradient of the tangent. Now let's calculate the equation for the tangent. It's gonna be y minus y1 equal to m open bracket x minus x1. Then substitute. So where there's y1, you substitute these coordinates, go y1 or x1. So it's gonna be y minus y1 or 2 equal to, what's the gradient, to minus 3 over 4, and then it's x minus x1 ubani 4. So it's y minus 2 negative 3 over 4x, then la kuba plus 3 when we multiply negative 3 over 4 nalo 4 so plus 3, then it's gonna be y equal to minus 3 over 4x plus 3 plus 2. So y is equal to minus 3 over 4x plus 5. This is our answer here. This is the equation for the tangent at point L. Determine the coordinates of the point at which the tangent in there cuts the x-axis. Determine the coordinates of the point at which the tangent. Okay, so they basically want us to calculate the x-intercept of this tangent. Bafuna sithole ama coordinates wala. So 1.2.3, sizothatha this equation and say let y be equal to 0. Let y to be equal to 0. So thola the x-intercept of that tangent. So 0 is equal to minus 3 over 4x plus 5. Then we transpose this one, about 3 over 4x equal to 5. Then we divide them with 3 over 4, 3 over 4. Zia cancel, then you find that x is equal to 5, 5, 3 over 4. Then it's 20 over 3. Therefore, your x-intercept is 20 over 3 and 0. These are your coordinates. 1.2, done and dusted. Next one. Sizala. We come to this one, 1.3. Alright, this is an interesting problem. A very interesting one. Sifuna the coordinates. We want what? The coordinates of t. So, the coordinates of t, in fact, you know what? Let's just read the statement. In the diagram below, AB is a tangent to the circle O at point T. The equation of AB, 9. So this tangent, line AB, is a tangent. And the point T, they don't mention this in the statement. It's actually a point of intersection. A point of intersection. It's where two lines meet or two functions meet and they cross each other, or they cross each other or intersect each other. Ne? So that point of intersection, it's where two lines meet. It's the tangent as well as the radius. Fortunately, they gave us one equation, which is the equation for the tangent. So ngizodinga the equation of the radius, this equation, then ngizowathatha ngiwasolve simultaneously. So ngifuna the equation of line TO, the radius. Qala ne kuqala, check again, check. So the first thing I'm gonna do, I'm gonna say, since ngifuna the equation for the straight line TO, ngidinga two things, gradient and a point. Guess what? We do have a point along the line TO, 0 and 0. That's also considered a point. So in order to get the gradient for the line TO, ngizosebenzisa the gradient of line AB. So line AB has the following equation: y is equal to minus 2x minus 5. We know that the line of a straight line, it's always written like this. If it's not written like this, we rearrange or just simplify further such that it gets to this point. So I can see that the gradient for the line AB, it's actually minus 2. So when we take e gradient ka line AB and multiply it by the gradient of line TO or OT, gives us to minus 1. Ngoba the AB is perpendicular to the TO. We know this, a tangent and a radius are always perpendicular, or a radius and a diameter, or a diameter and a tangent are always perpendicular to each other. Ne? It's either a radius or a diameter, that's about perpendicular. So I do have the gradient for line AB, yaifaga, and then it's minus 1 divided by minus 2, ziyakhansela. MTO is equal to 1 over 2. So this is the gradient of line TO. Now I can use this gradient to get the equation for the line TO. So it's y minus y1 equal to mx minus x1. So it's y. Where there's y1 or x1, you substitute the point lam. It's that 0, 0. So it's 0. M will have x minus 0. So y minus 0 is just y, and then 0 minus x minus 0 is just x. So you multiply ngalo half la. This is what I end up with. No matter how foil, but you'll see after foiling this and this, your final answer is gonna take you straight to half x. So this is my equation for the straight line. So I'm gonna call this equation number 1, and call that one equation number 2. No mungati 1 this one, 2 this one, it doesn't matter. So ngina 2 yama equations that I need to solve simultaneously. I'm gonna equate them ngoba it's y equal to y equal to. So where there's y lapha ku equation number 2, I'm gonna substitute half x equal to minus 2x minus 5. What I did was I substituted the equation 1 into equation number 2. So where there's y, I substitute ubani half x. Then siyasolve lo 2 zangapha kuba half x plus 2x equal to minus 5. What's a half plus 2? That's at the end 5 over 2. But let me just double check. Yes, it's 5 over 2x equal to minus 5. Then we divide that with 5 over 2, 5 over 2. They are cancel again. Then we have a minus 5 over 5 over 2. It's just going to be a negative 2. So x is equal to negative 2. Bega, we now have the first coordinate, which is x. Remember, sifuna coordinates got t. Sifuna both the x and the y. So to get the y, you substitute the x into that equation. So y is gonna be a half, where there's x in fagu minus 2. So final answer is just minus 1. It's minus 1. Minus 1. So the coordinates for t are gonna be minus 2 and minus 1. So this is our answer. Here we go. Our coordinates got t. 1.3. Done. Next one. Next one. Sesingena ku question 2 ke manje. Yabona? Yeah, siyaqeda. All right. So in the diagram below, a circle with center M is given. A is a point on the y-axis. Nangu A lapha. It's the y-axis. So kufana nokuthi it's the y-intercept of the straight line AB. You can also say that. AB is the diameter of the circle. CD is the tangent to the circle at point B. Began man. It's the same story repeated over and over and over and over. Circle, tangent. Get the equation of the tangent. We told kanjani ke? I told you. All right. So Bafunas calculated the coordinates of A. All right. Maybe nah. But anyway, check. This line AB, it's a straight line. The straight line AB. Right? This is a straight line AB. And it happens to be a diameter of that circle. Ne? Of that circle. The coordinates M found in the center of the circle are what we refer to as in midpoint. It's the midpoint of the line AB. Now, in order to get our coordinates A, so inside the midpoint formula. So like 2.1.1, we're gonna say M is 3 and 1. This is equal to M, it's XA plus XB over 2. YA plus YB over 2 equal to density M. What are the coordinates for AXA? I don't know. Ngifaka XA. Ama coordinates esiwafunayo by the way. Plus XB ubani 6 over 2. Then OYA, I don't know. Plus then we say when YB it's negative 3, we substitute, divide by 2, close bracket. Then it's M, that is 3 and 1. So if ama coordinates ka A being now, bese ngithi ngiyawa substitute la, ngiqhubeke nale calculation, I should get u3 as a final answer, I should get u1 as a final answer la. But as now ama coordinates ka A, so we're gonna have to calculate them. So since lo 3 komele alingane naloku, lo 1 komele alingane naloku. So I'm just gonna equate them, meaning that ngizoti 3 you are equal to XA plus 6 over 2. This is an equation on its own. You simplifier, and get i-value kabani ka xa. So xa I want to calculate. You divide that by 1 over the left hand side. Basically cross multiplier. 2 times 3, that's 6. 1 times that is just going to be xa plus 6. xa plus 6. Bese lo 6 ngiyamtranspose uza ngapha. Uyabo ukuthi x wami ubani u0. It makes sense, vele. It actually does make sense. Ngoba this is the y-intercept of the straight line AB. So it's sitting on the y-axis. So x vele komele kube u0. So then for the y value, I'm just going to say when I 1, you are equal to ya minus 3. So the positive and the negative, basipu negative 3. Mang remove that bracket. Then go about 2 over 1, cross multiply. 2 times 1, that's 2. 1 times that, it's y minus 3. Transpose all 3. Go about 2 plus 3. Ya. Then go about 5. That's ya. So the coordinates for A are gonna be 0 and 5. So I totally like it now. 2.1.2, determine the equation of the tangent ke manje lapha kubani ku point B. Do you see that it's the same story repeated over and over, or let me say the same questions repeated over and over and over again? Nyocula the same song nala. I'm gonna sing the same song. Get the equation of this radius, or you can also get the radius of that, the gradient of that diameter, or you can get the gradient of this radius. Sikwenza kanjani ke lo? Tatu M no B, you get the gradient for the radius. After getting the gradient for the radius, you can use it to find the gradient for this tangent. Ngoba whenever we find the equation of a straight line, we need what? We need a point and a gradient. So since it's for the equation of the tangent, that's what's going to happen here. So 2.1.2. So kalang a gradient. So the M BM, the gradient of the radius M la. Then go about XB, go about XM, equal to what is YB? Negative 3 minus what is YM? 1 over what is XB? 6 minus what is XM? 3. It's minus 4 la. Then 6 minus 3, that's 3. So your final answer is minus 4 over 3. So that's the equation for the radius. Then we're gonna find that's not the equation, that's the gradient of the radius BM. So the gradient ka BM, when multiplied by the gradient of the tangent DC, is equal to minus 1. Substitute la, minus 4 over 3 multiplied by the gradient of the tangent DC, which I don't know. We calculate. So I'm gonna divide by minus 4 over 3. Cancel. Nangapa minus 4 over 3. MDC is equal to 3 over 4. A positive. Now we shall go calculate is that. Now to get the equation, same story, man, guys. Same story, same preaching, same message. I change. Yafana ne gospel. Yafana ne ndaba kaJesu. Okay, so y1 ubani? Okay. I'm lago y1 no x1. I'm gonna substitute the point that lies on the tangent. So y1 negative 3. Gradient 3 over 4. X minus x1 6. Then go by y plus 3. Go by 3 over 4. X. Yeah, muslana nga multiply la. So go about 3 over 4x. Then 3 over 4 multiplied by negative 6. 3 over 4 multiplied by negative 6, or negative 9 over 2. then it's y equal to 3 over 4x minus 9 over 2 minus 3. Then y is equal to 3 over 4x minus 3. Then it's negative 15 over 2. I hope you'll tolerate the calculation. So it's minus 9 over 2 minus 3. Yes, negative 15 over 2. So that's the final answer. Okay. Hayi ungayipause i-recording bese uthatha i-break kancane. Yabona? Bese uyabuya futhi. Ngoba manje kuyashuba. Kuyashuba. Yo. Ngiyadlala mara kuyashuba la. I don't wanna lie. Okay, so the equation of the circle with center. All right. Some of the questions you can do without any problems. Uma ngithi ziyashuba lo 2.2.3, it's a very interesting problem. Very interesting, quite interesting, but it's not difficult to understand, just it's an interesting one. Okay. Uzobona so shesha siyiqede nale problem. So the equation of the circle with center O is x squared plus y squared equal to 36. Bese bathi circle O ikhatha the x-axis at S. Now, ibuye ikhathe okay, so the y-axis is not labeled. Then bese bathi kuno Q, which is the point 2A nange lapha. It lies on the circle. Then kuno R, which is a point that lies outside the circle, is a point in the first quadrant. Ne? Then bawa connect alama points ngama lines. 2.2.1, write down the length of the radius. Okay. Alright, now equation of the circle 36. So it's 36. The equation in its general form now, it's x squared y squared equal to r squared. Whatever value you get on the right hand side, it's a squared value, meaning that in order to get your radius, we calculate this. So r squared is equal to 36. The 36 is a radius that is squared. Now to get the radius, we take the square root on both sides. So r is now equal to 6 units. And your radius, it's gonna be a positive. Now square root a number, it comes out as a plus minus 6 in this case. Ngoba we want a radius, it's gonna be a positive 6, not a negative 6. Okay. So now I answer you for 1 mark. 2.2.2, calculate the value of A and leave it in SAT form. For 2 marks. Alright, so we can see that from the sketch, the Q, it's a point that lies on the circle. It's a point that lies on the circle. We want a value gabani ga A, which happens to be what? The y coordinate of that point Q. So, x squared y squared equal to 36. So where there's x, you substitute to 2 squared, plus where there's y, you substitute to a, so it's a squared equal to 36. Then from here it's obvious, you just need to calculate and solve for bani a. So it's 4 plus a squared is equal to 36. We transpose 4, it's now a squared. 36 minus 4, a squared is equal to, what is 36? It's 32. So the square root of 32, I need to square root both sides. Then a is equal to plus minus, by the way, plus minus 4 square root 2. Bigger. The a, or the point Q, lies in the first quadrant, so it means that both the x and the y are zoba positive. So a wami, it's gonna be a positive 4 square root 2. That's a. Then 2.2.3, determine the coordinates of r if OQRS is a parallelogram. Okay, so the first thing is actually the following. I think label this coordinate to be 4 yarasa lekhala asifake la yoba wani u4 square root 2. So that's the coordinate A. That's coordinate A. Alright, that's coordinate A. So sizalapha ku 2.2.3. Determine the coordinates of R. So into yokuqala esizoyi-calculator la is actually that coordinate S. You'll understand just why sifuna coordinate S. Ne? It's okay. I think you explain why this is la. For the coordinates waga R, I actually need i-value kabani ka M no N as well. Ne? Because Q no R are being connected by a horizontal line, the same line, meaning that bazo share a common Y coordinate. So it means that already says na value ka N, which is that square root, that 4 square root 2. The Q and the R will share a common Y coordinate. Bane coordinate efanayo, meaning that the Q and the R will have the same Y coordinate. Ngoba they are sitting on the same horizontal line. Check. So we have to calculate ubani u-M kahle kahle. So u-M akahluphi here, but it's just a matter of understanding the logic la, ne? Uma uthatha ukubheka uyabona the coordinate okay, le point la ka R, ne, liya corresponda ne point la ka bani la ka, okay, what am I saying? Le point la ka Q li corresponda ne point la ka bani la ka R. If ngithatha u-Q ngimshifta by 2 units, for example, no R na you shifta by how many units? 2 units. So uma uthatha ukubheka vele this Q measure how many units? 2 units from the origin. 2 units. So kuchaza ukuthi no R naye uzo measure how many units? 2 units from S. 2 units from S. So ngoba uQ is being measured from the origin to Q, it's gonna be 2 units. That's why it's told 2 la, ne? But u-M yena is being measured 2 units from S. Kuzofuneka usithola ama coordinates kabani ka S. So that ukuze ngithola ama coordinates ka M, ngizothatha le coordinate la ka S ngil add na 2 units and get ama value kabani, ama coordinates kabani ka M. I think erase la. Ngikhulume too much. Let's start doing. So lana sithi ze A, it's 4 square root 2. 4 square root 2. Alright, so 2.2.3. We start off by calculating our coordinates ka S, which by the way, the S coordinate, the S point lapa, it's what? It's the x-intercept. So sifuna the x-intercept where we let y to be 0. Where we let y to be 0. So this is the equation equal to 36. This is the equation. So we let y to be 0. So for the x-intercept. So 0 la squared is equal to 36. Then sibano x squared. 0 squared is just 0. So kufana nokutaga akekho lapha, right? Or abanye bazo complain mara uyephu 0 lapha. Nangu 0 la. 0 squared is 0. So x squared plus 0 is just x squared. This is where I was going. So taking the square root on both sides, x is now equal to plus minus 6. But to x wami uzoba 6 or positive. Ngoba the point S is sitting on the positive x-axis. Alright, so x is equal to bani 6 for US. So the coordinates for S was 0 and 6. So nalana it's what? It's 6 and 0. So lana the coordinates were what? Were 0 and 0. So basitshele ukuthi okay, the coordinates for Q ubani, it's 2 and A. So So if the coordinates of Q are 2 and A, right, are 2 and A, where the A is 4 square root 2, uma usuka la ku-origin uza la kule coordinate la ka-Q, umuva by 2 units. It also means that u-R ngoba aya correspond lama points, u-Q no R aya correspond. Whenever Q shifts, no R uzo shifta. That's a property yani ye parallelogram, right? Ye parallelogram. Oh, by the way, even our opposite sides are equal, they are also parallel. Our properties were parallelogram now. Alright? So R, we are shifter, no Q, we are shifter. Since we shifted by 2 units, or let me just say, we measure 2 units from this point. From this point, no R na komela measure 2 units. But ngifuna ama coordinates kabani ka M. Lawo ma coordinates ka M ngizothi ke R is actually equal to the coordinate laga S, the x coordinate laga S, which is 6 plus 2. Why? Ngoba R shifted 2 units. Jengo Q shifted 2 units. So I'm add on top of that 6. I'm going to add on top of that 6. So the y coordinate yaga R I did discuss ngati it's that n. Right? 4 square root 2 uzofana no A 4 square root 2, so that's 4 square root 2. Then R 6 plus 2, that's 8, 4 square root 2. So these are the coordinates ka R. Now for the last question, 2.2.4, what type of parallelogram is OQRS? Give reasons. I think Rabela. Just for 1 mark, it's a rhombus, ne? It's a rhombus. Anyway, as we discuss some shapes la, but sometimes it's good to know. It's a rhombus. It's because of equal sides. Equal sides. We have to give a reason as well. Ne? It's equal sides. Back. This OS, it's a radius. This OQ is a radius. And then we know that from our properties with parallelogram that opposite sides are equal. So since lingana na le, it also means good lingana na le. In fact, wonke lama sides are lingana. And a rhombus, ama sides wakhona wonke ayalingana in a rhombus. Okay? That's 2.2. Done. Done. Now for the last question. For the last question. So Lana, same story. Same story. 2.3. Same story, guys. So in the figure below, C is the center of the larger circle, Naila, and lies on the x-axis. The smaller circle with center A intersects the larger circle at point B and at D as well. I'm points of intersections now. Then BC is a tangent to the smaller circle at B. Now, so this means is a tangent. This yellow line is a tangent. Alright, then go 2.3.1. What is the equation of the smaller circle in the form? So we have to find the equation. Okay, that's easy. Ngawar. So no 2.3.1. On this equation, x minus a squared plus y minus b squared is equal to r squared. So we know that a no b our coordinates were sent. See our substitute. So the x minus 2 squared plus y minus b ubadi 3 squared equal to, we don't have the radius, but don't stress. So you have our coordinates were center. A, it's captured. Now sufuna ama coordinates wani, okay, not the coordinates, but sufuna I value gabani ga r, the radius. So since B also lies on the circle, so in order to get r where there's y and x, you substitute the second set of points, second set of coordinates B. So that's your calculate ubani r. So you need to open bracket where there's x in your fago 4, then it's minus 2 squared la. Then where there's y in your fago 5, so it's gonna be 5 minus 3 squared equal to r squared. Then you subtract along total 2 squared, it's gonna be 4 plus lana minus lana, that's 2 squared, it's also 4 equal to r squared. So it's 8 r squared. 8 is equal to r squared. So we have the radius squared. I'm gonna leave it here. Then ngibuyele back to this equation, the state of this equation at that point where the center is substituted, and just substitute r1 squared, r1 squared. So it's 8. This is the final answer. This is the equation of the smaller circle. Now we have to find the equation of the tangent B, tangent BC. Okay, same story, same ganegwane, same story. Okay, you find what? The gradient of the radius, and then you use that gradient to find the gradient of the tangent. Then you use that gradient, you just calculate it of the tangent, and this point, then you find the equation of the line of the tangent BC. Okay, so gradient AB is equal to YA minus YB over XA minus XB. Okay, then I'm gonna erase that. So what is YA? YA 3 minus what is YB 5 over what is XA 2 minus what is XB 4. 3 minus 5, it's minus 2. It's minus 2. 2 minus 4, it's negative 2 as well. So your answer 1. 1. Yeah, it's 1. Therefore, gradient of AB, which is the radius, multiplied by the gradient of the tangent, which is gradient tangent, it's BC, equal to minus 1. Therefore, ufagu 1. BC is equal to minus 1 over 1 over 1. Then so about our BC value minus 1. Aga escape. Therefore, you're gonna come back and substitute here. X minus x1, then uthi y minus y1 uban, y1 uban. You're gonna substitute the coordinates of B. So y1 is 5 equal to what is the gradient to minus 1. X, what is x1? 4. Then y minus 5, you multiply by negative 1 over minus x plus 4. Then you transpose 5. Then you end up with 2 minus x plus 9. This is your final answer again. Then this is your final answer. Okay. Then lapha ku 2.2.3. You have a situation where but yes, a student claims that the coordinates of D are 2.5. Is the student's claim true or false? The student sithi man lalela mngana. Listen man. Lama coordinates D has the following coordinates. Uthi ngiwacalculateile. Ngiyongitshela next. 2.5. Yeah, ama coordinates waka D la. Okay? Then but you see substantiate by showing our calculations if this is true or false. Ne? So how do you prove that? All right, so we just calculated the equation of the smaller circle. Naila, it's right here. Okay, no, it's this question. So what are the coordinates? I mean, what is the equation? Naila. So pendula 2.3.3 using this equation. Sizoti. Since it's x equal to 2, y equal to a half. Ne? Y equal to a half. Oh, by the way, it's squared la. X is equal to 2, y is equal to a half. So, thina ke, so tata y simsubstitute la. Sithatha x simsubstitute la. Komele sisolve after we have to find the value, or we have to punch whatever we're gonna have in the calculator and see that if siyamthola u8. If asimthola u8, it tells good the coordinate d is not the answer. Okay, back. Coordinates got d they lie on the smaller circle as well as on the bigger circle. Ne? If the point 2.5, if the coordinates 2.5, they are the coordinates of d. Komele ukuthi naswa substitute onto this equation of the smaller circle. Komele satisfy that equation. Ne? Meaning that nangifaka x la ngifake no y la, komele kuphume u8 to show ukuthi actually vele lama coordinates ka d, they do lie on the smaller circle. If lawo ma coordinates naswa substitute and as told 8, it means that the coordinates 2 and 1, they do not lie on the smaller circle. Therefore axima coordinates ka d. Let me show you. Sizala sithi ke x u2 minus 2 squared plus y u1/2 minus 3 squared equal to siyaqhubeka la 2 minus 2 0 squared plus what is 1/2 minus 3 1/2 minus 3, okay, that's -5/2 squared. So your answer is 0 la. Then it's totally answer with 2 bani lapha u25/4. I think so obvious go to 8 akaphuma no matter what we do over 4. Then siyabona ukuthi hayi man u25/4 is actually not equal to 8. Therefore we are conclude that d should okay. Therefore uzothi mhlambe 2.5 are not coordinates, are not the coordinates of d, are not the coordinates of d. All right, section B. What umsebenzi. That was quite a lot of work. Okay, I hope you enjoy it. I hope you told something. I hope so master really analytical geometry by this point. After watching this whole video. Nangabuni question, asikhulume grouping, or let's talk in the comment section of this recording. For now, I'm signing out, guys. See ya.